All right, welcome. I'm here with Matt Mueller from Prisma, and this is the kickoff to kind of a new series we're doing where we're talking with Prisma people inside Prisma, engineers, people who really know the stuff that's going on and the inner workings. And so Matt is one of those people. He is on the Prisma client team. And Matt, welcome. Thanks for doing this today.
Yeah, it's great to be here. Thanks, Ryan.
Yeah, and so you are I guess you lead the Prisma client team. Would that be fair to say? You kind of manage the team?
I'm the product manager. Mm-hmm.
Okay, awesome. So, you manage the team, and how big is the team now? It's, I think from what I've seen, it's like at least 6 or 8 people. Is that about right?
Yeah, it's about six people.
Okay, excellent. Mm-hmm. So lots going on with Prisma clients, of course. And I mean, you've touched a lot of stuff database-wise in your time at Prisma and elsewhere, I'm sure. And one topic that you wrote about recently for a guide within our docs is on transactions specifically. And this is a topic that I think deserves some attention, some maybe a deep dive. And that's why I wanted to chat with you about that today, is to really kind of go a little bit deeper about transactions, give people a sense of what they're all about. It's a topic that comes up quite a bit in the work that I do at Prisma within DevRel, where people are asking about transactions and the transactions API that Prisma has, how they might accomplish certain tasks. And I think people's comfort level and experience level with transactions sort of runs the gamut. Like, you've got people that are fairly new to transactions and really need to start to understand like why you would use them, what they are, etc. And then there's people who have done a lot of work with transactions and maybe are trying to fit what they would typically do with transactions into the Prisma model. Maybe they run up against some unexpected behavior in terms of what they want to do with transactions versus what you can do in Prisma. So I'm hoping to chat with you about all sorts of stuff on transactions today. And I think maybe just to kick it off, we could talk about like what a transaction is, when you would want to use it, and that sort of thing. So give me your take. What is a transaction, and what's it all about? Why is it important?
Transactions are like a super interesting topic for databases, and I think the best way to maybe describe a transaction is using like a classic banking example. And so the way to you can imagine, like, if you're transferring money from one bank account to another bank account, you are like, say you send $100 to your friend, like me taking $100 out of my account and sending it to the $100 to my friend's account. Those are two separate operations. It's one subtracting $100 from my account and adding $100 to the other, like my friend's account. Those would be two separate operations. But with a transaction, like you don't want to subtract and then some failure to happen and then your friend never receives your $100. And then $100 just vanishes into midair. You also don't want somebody sending $100 in 2 different places and then it's suddenly $200. So you want those operations to be kind of like melded together into like one atomic operation. And so that's what transactions provides. It provides a way to kind of treat these 2 different distinct operations on the database as one operation that either all succeeds together or fails entirely.
Gotcha. Okay. And so it's, I guess you could take a really simple scenario where you've got to update maybe like one table, maybe a few records within a table. You can do that within, a SQL statement, or like if you're going through Prisma, through a Prisma update or whatever. And if you just have like a couple records within a single table, that's pretty cut and dry. I think you can just make that update. There's not really too much else to worry about. It's either going to succeed or it's going to fail. And since that's your single table of interest, there's not much else to do except for, notify the user they need to try again or whatever. But I guess transactions are really key when you have a series of things that you need to do, right? With various tables. Maybe you even have to do one thing in your database, then go run some logic, maybe even hit like an external API or something, then come back and do the other stuff that you need to do in separate tables. Or maybe it's the same table, but it's another operation that you need to do. Would you say that's fair? Is that kind of the idea with transactions? It's like encapsulating all these separate operations. Could be very many, could be just a few, and really just stuffing them into something that looks like a single transaction. I think that's what you're getting at, eh?
Yeah, that's right. It doesn't necessarily have to be separate tables. Like it could just be multiple people wanting to edit the same data within one table. It's really about just like making sure that multiple operations appear as one single like action
Right.
or one operation. Yeah.
Gotcha. So I think, I mean, the takeaway for me is that transactions are really key if you can implement them, because then you don't have to handle that failure logic yourself. I think that's what, I mean, outside of transactions, I think that's basically what you've got to do. I've seen various scenarios where, like, if you do one operation and it fails for whatever reason, or let's say this, if you do an operation and then maybe another one, and then there's a third that third fails, and let's say that those two upstream ones maybe created a record or something like that, but then the third one fails. If you don't do transactions and if you don't handle the failure on your own, what you're left with is maybe some inserted data for those two initial operations, and then the third one fails, whatever. I've seen cases where people will just be like, whatever, I got some data in the database that really we can just discard. Maybe it still exists in the database. To me, that's not very good for database hygiene. Now you've potentially created all sorts of records that you're not going to use. Who knows if that's going to lead to data corruption, etc. And then I've seen, so from that side of it, I've also seen where people are handling the logic themselves, where they're going to say, okay, if operation 1 passes, move on. If 2 passes, move on. But if 3 fails, then take the IDs maybe that we inserted for those first 2 and then go delete them. Do you see that very much, or what's kind of like a naive sort of implementation if you're not reaching for transactions?
I think it's probably the first one you described, where it's like we just accept the potential for data bugs, and we've got some like leftover data from some of these failed operations or like midway actions that kind of fail somewhere in the middle. The former, or the second option you described, which is like being able to kind of recuperate like from failure, like you do see that, but the problem with that is like it's kind of like for every single one, like if you have 2, then there's 1 opportunity to fail. If you have 3, you've got 2 places you need to like deal with, and like it kind of just explodes from there.
Right.
And so like being able to kind of handle like the various states, like invalid states that you can be in, is just like a ton of work. Yeah. And also like the failures themselves, like the trying to retry or like do like fix your failures could also fail. So you're kind of in this like weird spiral of like it's just a challenge to code, like to code up. And so if you can avoid that kind of like those failure modes, like try to cut out them if possible, I would say.
Yeah, and that's where transactions really shine. So cool. Yeah. We'll get into transactions and how you might sort of implement them, what that, I guess, looks like at a high level. But one thing I wanted to chat on a bit first is this acronym that comes up when people are talking about transactions, and that is ACID. So, ACID is this acronym that we've got as, maybe some guidance for ourselves when we're dealing with transactions, or at least maybe that's the way that some people would think about it. You mentioned that it's not, maybe it shouldn't be treated as like a box to check off, but like how should people be thinking about ACID? Like what's the what do people do with this acronym? Is it something that they should be sort of looking at to see that they're implementing in their transactions as some guidance, or how should people treat it?
I would say it's mostly about like the design of the database itself. Like certain databases don't provide ACID guarantees, and it's kind of a set of trade-offs. Like if you have ACID, then like maybe there are certain things that are slower than if you didn't have ACID, because it's doing all these additional checks and whatnot, and like providing all these different guarantees. So it's really like it's not necessarily something that comes up, I would say, like day to day of like using transactions. It's mostly like when you're going to pick a database, right. Like is it ACID compatible, and then what does that actually mean? So kind of digging into those details. And most of the modern databases, SQL databases are like they do provide ACID guarantees. But like for NoSQL databases, that's not necessarily the case. For key value databases, that's not the case. So you're kind of just choosing different trade-offs.
I see. Okay. So it's not so much like something that developers would be, using to code against necessarily. It's like it's a feature of a database that you might be evaluating. Okay. So,
Exactly.
and yeah, I think, I think I've heard that statement before that NoSQL databases don't provide ACID guarantees. So why is that, I guess, at a high level with NoSQL versus SQL databases?
It's important to note that like some NoSQL databases do provide some ACID guarantees, like Mongo, but it's mostly a trade-off in performance. I would say like you do have to do all this additional like to keep the transactions isolated and like make sure they end up in a consistent state, and like there's a bunch of like bookkeeping that's involved, and like NoSQL is designed, or what like originally was designed for like very highly scalable, very simple key value stores. Like when you think about like the origins of like with like DynamoDB and stuff like that, that was coming out of Amazon realizing that a bunch of their microservices were literally just like they just needed to write data and read data very simply. They didn't need these transactional guarantees, and so adding ACID on top of that has performance trade-offs, and it's just a lot more complicated as well. So if you can kind of get away with not having it, then that's great. But it really depends on like what you need your database to do.
Gotcha. Okay, that makes sense. Okay, cool. So that's a little bit of, I suppose, the theory about transactions and some of the accompanying nomenclature. What does a transaction look like? Maybe we could think about, we'll talk about the Prisma way to do things, but let's think about maybe just like a bare bones example, not using Prisma. Let's say we're using like a SQL database, whatever, Postgres, and we're coding something up in a node.js backend. Like just so people can sort of get a conceptualization, like what does a transaction even look like code-wise at sort of a high level?
Yeah, sure. I think like one maybe familiar example is like if you look at maybe Notion or Slack, they've got like when you create a user, like you're also put in a team or you're put in a workspace or something like that. And so like if we're looking at maybe like implementing the initial sign up workflow for let's say Notion, the initial sign up workflow is like the request comes in to create a user and a team. You don't really want to create a user without a team or a team without a user. And so like you want those kind of to be linked together. Like you create the team and the user is a member of that team.
Right.
If you have a user without a team, like it all kind of depends on how your application code deals with it, but you're kind of in a weird state where like your application may break if you didn't make the assumption that a user can have no team. And so I think that's like one example, but they show up all over the place. Like whenever you're basically needing to do multiple operations and you kind of want to treat it as like this is an all or nothing thing, and you don't want to be in a state where like something worked but then something didn't work.
Right. Okay. And so like if people were going to look at some code for this, because I know there's like I suppose you delve into maybe the SQL end of it, and also maybe you have to deal with code in your Node app in this example we're thinking of. But what are some of these keywords that we're dealing with? Like I think I've heard some of them, like commit would be what you would do at the end, right? But there's some other statements I think in there, right, to deal with transactions. What would they be?
Yeah, if we look at like the SQL, kind of the raw SQL query syntax, you've got your begin, and that's basically like begin the transaction, and then you run inserts, selects, updates, deletes, whatever. And then at some point you'll either have a commit or a rollback. And basically like oftentimes what you do end up doing is if something fails, you automatically roll back. So you'll often put this in a block, and then like the rollback's kind of implicit. And then if the whole block succeeds, then you add the commit at the end, like the commit command, and then that will commit the transaction.
What's happening under the hood when you're doing when you're stepping through that block? Like, are you actually inserting the data into the database? Let's say the scenario where you have to do some inserts, then you do a read, and then you've got to insert something else. Are those inserts actually happening, or are they kind of like in this, like pseudo insert until you've guaranteed they could all succeed, and then you commit? Or do they go into the database and then come out of the database if you have to roll back?
Yeah, they are in the database. They're in the transaction of the database, and that transaction is isolated from the rest of your data.
Okay.
And so once you do commit that, it's kind of like pushing it into the database. But like you're kind of in almost like a scratch space.
Okay.
Of like doing all this work, but you're able to still kind of read values. So it's not exactly like completely isolated, but you're still able to read some values from the database, kind of working in this like almost staging area, and then you commit.
Interesting. Okay. And so, and that within that scratch staging space, like you would get like let's say you have to insert some data, you would get an ID for that. Like maybe you've got an auto incremented ID. You would get the appropriate ID for your insert, and then that would just, I suppose, how would that work though? Like if you had something that's auto incrementing and you were running a transaction and it said, okay, let's get the number 20 because that's the next one to insert, and then you roll it back, does that auto incremented ID become unavailable, or does it free itself back up? Because let's say you had other inserts that were happening alongside that or whatever, right? I wonder how that works.
Yeah, I think that's a implementation detail of the database. Like I think it may depend, but my guess is that it's like an atomic counter, and so like it's kind of like there's many different things that can increment this counter. It's called a sequence in a database, and I don't think it would actually go back down. I think it would just constantly go up, and like it's usually not a huge deal for your auto incremented ID to skip some numbers. So gotcha.
That makes sense. Cool. Okay, so that's what it looks like in SQL. Like if you're dealing with raw SQL. Let's, I guess, talk about how you would treat it in Prisma. I know that there are various ways that you can think about transactions in Prisma, and we'll link up these docs here. We've got some docs, things like a transactions reference guide, and then there's like another, I guess there's like a Prisma guide on transactions as well. They talk about various ways that you might think about transactions in Prisma. And, the first one that you might look at that would be considered a transaction is if you have to like let's say you create a user and then you want to attribute some other resources to that user, maybe like a set of posts, so that you could do like this nested create within a user creation. So that's maybe one of the easier ways to think about a transaction in Prisma. But is that right? And like what else can you do transaction wise in Prisma? I guess let's delve into that. Transactions as they pertain to Prisma.
So Prisma supports quite a few different transaction use cases. We support when you do nested writes, so you create a user and then you create many posts. You can do that all within one Prisma command, and that Prisma command is itself a transaction.
So is that under the hood when Prisma is writing the SQL to do that? Is that like that's a transaction block like we've talked about with the begin and then the commit and everything? Okay, gotcha. Yep. Interesting. Okay, so that's one of the supported ways to do it. What else do we got?
We also have like a dollar transaction API, and that's for often like inserting data between different types of tables. That's like we do that, and then also like create many, find many. Update many, delete many. Those are all done. Like all of the items are inserted, updated, deleted transactionally.
Okay, interesting. So
I think the mental model to think about that is basically like if it's a single Prisma block or a single Prisma command, and you're doing many things within that command, then that's all within the transaction.
Gotcha. Okay. So one thing that comes up quite often, as I'm sure you know, is this question about long-running transactions within Prisma. I actually I haven't gotten an update about where we might be at with long-running transactions in a while, but let's talk about that. Long-running transactions, can they be done in Prisma these days? Why would people want to do them? And kind of if we can't do them in Prisma, why is it that we can't?
That's a good question. I think what they are maybe is probably the best way to start. Yeah. And so like what you think of as a long running transaction is like, say you're like at the opening of your GraphQL resolver or something, you've got like this begin command, this begin SQL command. Then you're doing like a whole bunch of stuff within that. Like you're maybe writing to the database, maybe you're like pinging Stripe or something like that, and like you're doing a whole bunch of other stuff. And then at the end of that, you run commit. Mm-hmm. And so it's kind of like a bunch of different kinds of operations that aren't necessarily all database related. You're doing all within a transaction. And that's like a very easy way of using transactions and keeping your database in a consistent state. The problem is it doesn't scale. And so like when you're like transactions under the hood are using locks on the database and the tables, the rows of the tables. And so if multiple people are trying to like edit these rows, you end up with contention issues, locking contention issues. And so that approach is like often always a bad approach. And so that's kind of why we're trying to design and develop use cases that avoid the need like to do that kind of like start the block way up here and like commit the block way down here, because it's like often you'll end up like shooting yourself in the foot by doing so.
I see. Okay. So the approach we're taking is to try to guide developers away from that, because it's a foot gun, and instead do something that's a bit different. So let's take that scenario that you were talking about, like do some stuff in your database, ping the Stripe API for whatever, come back to your own API, do whatever else in your database. What's a better way, or just like conceptually, what's a better way to think about that kind of thing when you're implementing that kind of feature at your API? What's a better way to think about it?
So that's like, I think one thing that people maybe don't like necessarily appreciate about long-running transactions is, like this kind of use case is they reach for long-running transactions by default. Like they'll say like, okay, this is like if I just begin here and commit down here, like everything in here is going to be consistent. But that's not actually the case. Like imagine like maybe we'll, instead of ping Stripe, it's like create a customer in Stripe. So we're actually taking an action on a third-party resource. Right. Like if that fails and we've depended on, like, it doesn't matter if the database is consistent, if the things that you rely on is like the data held somewhere else is not consistent with what you expect in the database. Yeah. And so you're kind of like in this weird position anyways. Like even if you use long running transactions, like it doesn't solve that use case. Like when your data is kind of split across all these APIs, like it is nowadays in like the modern, like how we make apps. And so the recommended way that if you can pull this off, this is usually the right way, which is try to make your REST APIs or your GraphQL resolvers, like try to make them idempotent. And what that means is like the same kind of like requests yield the same results. Right. And so if let's take maybe you're creating a customer and like maybe you create the user and then you create the customer in Stripe and then like you maybe charge them and then like maybe you flip on they're in the Pro edition or something like that. You should make it so that if two requests come in for that same user or to that same person, that you don't end up with two customers or you don't end up in this weird state in your database. And so just like making sure that each of those things, like thinking about them as this can fail, this can fail, this can fail, and this can fail. And like what happens if this fails? Like if this fails, you should probably do something else. Like, and so one way for the Stripe thing is like try to create, and if the create fails, then try to update. Right. And then it doesn't matter how many times you run this operation, you'll end up in kind of the same state.
Right. Okay. And so that's really like, I guess that comes down to just being a defensive coder, really. Like you got to anticipate failure at every point along the way and act appropriately. And there's actually an example in I believe it's the reference guide that we'll link up. It's Maybe it's not the reference guide. Maybe it's the other one. There's two of these here that people will see. But there's in one of these guides, the Prisma transactions guide, you've got an example of where you might see this to keep things idempotent. So again, idempotency, a given request will always yield the same result essentially. Where you've got to code defensively against that, because in one scenario, if the user doesn't exist, you would create it, and then in the other scenario where it does exist, you would go into your else block and you would instead update it or just give back the user that's already in the database or whatever. So I guess that's what it comes down to. And this is interesting. I've seen this myself. I had this issue a while ago where what was it doing? It was using the app was using Auth0 as like the authentication layer, and it was hitting their API to create users. I believe that was the scenario. And once that would be done, you would need to take that Auth0 user ID and store it into the main database for the application, so that it could be used to like do other stuff, whatever. And we're running into issues where and this is in Mongo, so like all these issues that come up with NoSQL and not having a proper schema, we're starting to really show their true colors here. But the Auth0 ID wouldn't be found, so instead you would get null if something happened at that create step with Auth0. And we're getting a bunch of nulls in that Auth0 ID spot within the main database, and it was causing all sorts of issues downstream in the application. So that, and the reason that was happening is because there wasn't like a good defensive check against whether or not that Auth0 ID would come back properly or not, right? So the fix there is like, you got to check to see if you get that user created, and if not, you've got to like roll back. And this is a perfect use case of what we're talking about. It's because like at first there was a record stored in the Mongo database, then it would go to Auth0 to create that user, store some metadata there, and then come back with an Auth0 ID and store it in the main database. So the fix there was like, if Auth0 fails, go and delete that thing that was just created. So a little bit of a headache, but nonetheless, this is, I think, a good example of where transactions, long-running transactions, aren't really the thing you want to reach for in that scenario. You just instead want to be defensively coding, I suppose, against it. Would you say so for that particular case?
That would be one way to do it. Sometimes that's a little like complicated. Like if you have multiple of these steps, it's kind of what we were talking about earlier with like the three different operations, and like you kind of need to like make sure that you have failure checks in both these. If you do make this idempotent, so if you like if you if you're like you write Mongo and then you write Auth0 and maybe Auth0 fails, you can also just bail from that function and then have your client retry and just like keep retrying like until it succeeds basically,
right,
or retry up to a certain point. And so that's like, I would say that's probably an easier way, depending on the complexity of how many steps you need to take. As long as this thing's idempotent, you can just keep retrying until it succeeds.
Right. Gotcha. Okay. Cool. Yeah. So lots to think about there in terms of what you might be wanting to code against as people are, using third-party services more and more. In the doc, the guide that you've got here, we talk about various scenarios. Like there's these three that I'm thinking of in particular. There's dependent writes, independent writes, and read, modify, and write. What is that sort of like? How you break those scenarios out? What are they all about? And like, what are some of the, I guess, available techniques for each of them? I'm thinking specifically on the Prisma transactions guide. We got this kind of table of the three scenarios, and they're different in many ways. I'd like to maybe chat about what's different between them and how to think about those three scenarios.
Yeah, dependent writes is kind of what you talked about earlier, which is like your Mongo ID. It depended on the next operation depended on your Auth0 ID to be created. And so this will be more for the Prisma guides, the transaction guide specifically. It's more for inside within the database, not across services. But anytime something depends on the other, like this data depends on this existing and this thing doesn't exist yet, you've got you've got a dependency. Like you need to create this before you can create this. Independent writes are where you don't have that linkage. It's like you can create this and this, or you can create this then this. Like it doesn't matter the order. And then like read, modify, write is like when you need to read some data you need to modify it, and then you need to write it. And like they can kind of like if they interleave with each other, like if you have two reads and then one like modifies, like then like you can kind of end up in a weird state, I guess. And a good example of that is like if you have a kind of a resource a shared resource like booking tickets, like booking tickets for an event, or booking seats or something like that at a theater. Like multiple people are trying to book the same seat, and you can't just have two people book that same seat. Otherwise, you've got a big problem at the theater. And so, like if two people read and try and like both people say that the seat is empty, and then like one person modifies or like writes it, and then the other person modifies it and writes it, then you can end up with this like kind of, it's called a double booking problem. And transactions help like deal with that.
Gotcha. Okay. Interesting. Okay. And then there's this one concept here that I don't know maybe too much about, at least in the way that we've got it here, but optimistic concurrency control. What is optimistic concurrency control, and what's that? How does that apply here?
Yeah, that's a strategy for dealing with that double booking problem. And that is basically you can attach a version to an auto incrementing version that always goes up. And you can basically make sure that if two people try to book, like you read the same value, you read that this seat is empty, and then you also read the version at the same time, like version one. And then a person tries to write, and when they write, they see they write that the seat has been taken, like booked, and they write the version gets auto incremented to 2. And so when the second person comes in and tries to write, and they see that their version that they have is 1. Oh, sorry. Let me just step back actually, because at that right stage, like they're checking if their original version matches what is currently in the database, and then they're permitted to write. And so like this first person that comes in is permitted to write because 1 is still the version of the database, and they write, and they've got a seat taken and version 2. And then this person comes in and like tries to book the seat that they've already read that the seat is empty, and they read version 1. But then when they compare to do the write, it's version 1 they have, but version 2 is currently available, like or currently written to the database, and then you can reject that. So it's a way to it's like a strategy for certain situations where you have these kind of like double booking problem. It doesn't happen for every application and not for every transaction, but it is for certain things you can reach for optimistic concurrency control. And that is often like always try to reach for idempotency if you can first, but then if you can't, then you can reach for optimistic concurrency control.
Gotcha. Okay. Very cool. Well, we should probably start wrapping up soon, but maybe one thing we can chat about before we do is like the dollar transaction API in Prisma a little bit more. What are some cases? I mean, we've talked about long-running transactions not supported by Prisma, but like if you're using the dollar transaction API, like what are some cases that people should not be reaching for it? Or maybe like, I don't know, what are some good use cases for it? And what are some use cases that maybe aren't so good for that API?
So like it's usually I would consider it like a fallback if all else kind of fails. Like the use case that we have in the transaction guide was actually quite hard to come up with, because like there aren't that many cases where we can't, you should reach for it. And the case that we were able to come up with was like when you need to have a transaction with multiple, I believe it's like you're interacting with multiple tables that aren't related to each other. So if they are related to each other, like users are related to posts, you could do that in a nested write. But say like you need to shut down an account, and like you need to delete like a whole bunch of different things, like all associated with the user, but for some reason some things aren't linked. Like it's a kind of a hard thing to come up with actually. And then like you may want to do that transactionally, and then you may use dollar transaction. I would say, but there's also a couple cases right now, but we're kind of incrementally trying to address them. Like if you want to upsert many like items at once, we don't have an upsert many API, but we're going to get one at some point. And so like those are kind of cases where like, okay, you can't do this yet, but eventually we'll kind of address that, and then that will be like more and more of an edge case over time.
Right. Okay. Makes a lot of sense. Cool. Okay. Well, great. This has been a really good chat, man. Is there anything aside from like the transactions guide that we've got that you would point people towards if they're interested in this topic in some more depth? Maybe even like could be some getting started material, could be just whatever. Anything you'd point people towards?
Not necessarily. Like I think there's like one I think useful YouTube video on like the double booking problem. So if you search for that, like I think that helped me kind of conceptualize why, like when you would reach for certain things and when you wouldn't. I think reading there's a blog post about like Stripe's idempotent API requests that I think was pretty interesting read, and how they can basically kind of tie, like they have a idempotent request ID that kind of flows through the entire request, and that just makes sure that like they're not double charging people or like making sure that all their systems like you can kind of ping this thing as many times as you want and it all kind of stays in sync.
Yeah.
That I would recommend that blog post. Maybe we can link to that. Or,
yeah. Okay. Excellent.
But yeah.
That sounds like a good set of resources, and yep, we'll link those up for sure. Where can people find you if you want to be found online anywhere? Where can people reach out to you?
Yeah, I'm at Matt Mueller, MattMueller. Yeah, just ping me with anything that's on your mind. And then also, if you're in the Prisma Slack, I believe I'm Matthew Miller on that. No, I'm Matt Mueller on that as well. So I would join the Prisma Slack if you're not already a member, and yeah, we chat there.
Awesome. Okay. Well, we will link all of that up. Yeah. Thanks again for sitting down to chat. I think this will be super helpful for people who are newer to transactions, or even those who have been using them for a while but just want to grok some more of the the concepts. So, thank you, Matt. Appreciate you being here.
Yeah, this was fun. Thanks, Ryan.
There we go. All right. So obviously that was pre-recorded. We're here live now, though. Matt, welcome back. Thanks for doing the chat with me a few days ago, and glad to have you back here so we can answer any questions that people have got. So yeah, I guess maybe to start this little post session though, anything that came to mind as you were kind of watching that back that you'd want to mention that maybe we didn't get to chat about?
No, I think we covered most everything. Nothing came to mind.
Okay, cool. Well, why don't we move into some questions then? And there haven't been a whole lot that have come through as the replay was going. So if anyone does have questions in the live chat, please feel free to post them and we'll answer them. I guess we could go straight to some stuff that has to do more with Prisma. Here is a question about the enterprise product that we're building. So if you've been paying attention at all to the roadmap and to things kind of going on brewing in the Prisma ecosystem, you may be familiar with the fact that we are building an enterprise product. We're building a cloud product, in fact. And we have a public roadmap that we can link up here. So let me actually just grab the link to this spot here. One sec. Planned initiatives. So I don't know. I think that's the right one. Let's put it down here in the post. Yeah. So anyway, sorry, I was just looking for the post there. The idea is here we have got some stuff that we're working on that will be like a Prisma cloud sort of deal. So if you're interested in enterprise products that Prisma might be offering, you can anticipate things that will make it easier for you and your organizations and your teammates to work together on databases with Prisma. So cloud product that's coming, and it's very early right now, but it's in the works for sure. The next question that we had along similar lines, I suppose, is what's coming for support in the future for other language support. As you may know, Prisma right now supports TypeScript, JavaScript, and Go. So Go is a supported language. We've got a client for Go. It looks like we're working on some other stuff too. Python, C#, those are, you can anticipate those in the future. The idea here is that since we've got sort of this central engine for Prisma that's written in Rust, we can really come at it from many different languages. We can create clients in many different languages, and in fact, Python and C# are anticipated for the future. If you have a request for a language that maybe we haven't talked about yet or haven't been thinking about, you can feel free to open an issue at our GitHub. So GitHub, it's Prisma/Prisma at GitHub, and talk to us there about what you might want to see in terms of language support. All right, so let's see what else we have here in the comments. We had one on, I'm not too sure that I remember what the context for this was. I think Redux Saga's take the latest API does the same thing. So that was at some point along the way. Mohit, if you have any more details about that question, please feel free. I don't know if you caught, Matt, what this may have been in regards to.
No, I'm not sure, unfortunately.
All right. So let's see what else we have got. When can we see a little bit about the MongoDB integration? The most requested thing I think that we've seen along this Prisma journey. Do you know, Matt, what we might anticipate? You are the Prisma client guy. What's shaking with MongoDB?
Yeah, so we are actively working on it. We have a development build that is available. It will break on you. That's just a fair warning. But we are starting to show it to some people. So if you would like to give it a shot, I'd love to share it with you. We can reach out.
Awesome. Cool. Yeah, I'm excited to see it, what it's all about. I've used MongoDB a lot in the past. I've definitely switched over to be more Postgres focused now, but MongoDB is definitely still something of interest to me. Here's one that I actually skipped over. Sorry about that, Ahmed. It's does Prisma handle race conditions? What can you tell us on that, Matt?
Yeah, for the most part, yes. There are a couple operations in certain circumstances, like upsert comes to mind across HTTP requests. So if you're modifying the same resource at the same time across two different API HTTP requests, they can interlace. And so we may fix this in the future. There's an open issue for it, but for the most part, it is free of race conditions. It's mostly just upsert and connector create that you have to be a little bit careful of. And we're working on docs for that right now as well. And we may address the underlying problem at some point in the future.
Okay, perfect. I missed another one from Gerline as well. Where is the beanie, Matt? Where did it go?
I think it's in the wash.
Okay. Where's the beard too? I think your beard was a little bit longer last time.
Very good.
Cool. So we have another one down here. The question is, does Prisma support PostGIS format for spatial queries? And this is something that we get asked quite often. I think that you can use PostGIS if you're using Prisma, but maybe there isn't first-class support for it. Can you tell me a bit more on that, though?
Yeah, I think you can use the raw APIs. I think introspection will work. You're right that there's no first class native support. It is our fifth most requested feature or something like that. So we will be prioritizing this soon. It just hasn't happened yet.
Okay, gotcha. So that, I believe, would be it for the questions that we have in here so far. So maybe we'll give it just another minute to see if anything else comes in. And as we do that, I'm going to review here to see if I missed anything. Let's see. I don't think I missed anything. There is a nice comment here by Tarun. Next.js and Prisma make scalable applications. I think that is true as well. A note on that, actually, one thing that we can plug is that sometimes it's a little bit tricky to figure out how to properly work with a relational database with Prisma in a serverless setting. So if you are using Next.js and you're using serverless API routes, so serverless functions, there are a couple steps to go through to make sure that your database connections are handled appropriately. And so what I'll do here is just do a quick search for Daniel from the Prisma team did a great video recently on setting up a Prisma app with Vercel. So deploying to Vercel, and I'll grab the link here, so that you use connection pooling. And I'll post it in the chat here. This is that video. He shows how to use connection pooling and using PG Bouncer to manage your connections. And so this is definitely something you want to do if you're doing serverless, because you'll quickly run into the case that the amount of connections coming from your serverless functions will just exceed what your database is capable of. So check that video out. Very good if you are working with Next.js. We did have another question that I saw from Sean. Sean asks, is there an ETA for Nexus Prisma plugin? Sean, I'm sorry to say that I can't give an ETA just yet. I think, though, the best spot to be looking at is there's a pinned issue in the repo for the plugin, and that's where we talked about, like the issues with the plugin, what our plans are, etc. And that will be the spot to watch, I think, if there's going to be any update on ETA. So have a look there. And yes, I believe that is it for now. So yeah, Matt, thanks so much again for doing that chat. It was a lot of fun. I'm hopeful that people will take a lot of wisdom from what you've shared and apply it to their own application. So thank you once again, and we'll catch you around.
Yeah, take care, Ryan. Thanks.
Thanks for watching, everyone.